Hi friends, welcome back. The last sessions we have seen the primary data structure, the simplest data structure called the arrays. And then we have seen the various functionalities that an array can help. And then we have seen the applications of the arrays. Later on, we listed the advantages of using the arrays, and finally we had some disadvantages. So to overcome some of these disadvantages, we get into the next type of data structure, which we call linked list. So linked list is another linear data structure where the elements, also called nodes, are not stored contiguously in memory, whereas arrays do require contiguous memory locations, but the linked list do not require contiguous memory location for all the elements we want to store. So here, what we do is the data, instead of storing in one location, we create one node. So the node consists of two components. One component stores the actual data, and the another component stores the address of the next node, or where the next data is stored. So it means in case we are having n data, and then we were trying to use array to store this n data, then we require the memory sufficient to have n locations, and each location should be able to store one data, and all these n locations should be in contiguous way, so they should be one after other, so that just through indexing we can access any of the element. But the problem there is, as the size of the array increases, the memory requirement will increase, and we may not have sufficient memory at one place to fit the array, and hence we have a problem. Instead of taking all the data at one place, we can think that wherever possible, we fit one data at a time. But the problem is, in the arrays, the data are put one after other, so that if we identify one data, then the next data will be available on the immediate next location, and so on. But here we don't have such option. Therefore, we need to specifically say where exactly the next data is located at. So all these things are fit in one structure called node, and this contains two components. One component will store the data, and the other component will store where exactly the next node is situated. So this example shows how a linked list is used to save four data. The first node consists of data 10, and the address is graphically represented by the arrow, and says that the address is saying that the next node is located here. And then going to the next node, we realize that the first component, that is the data component, says that there is an element value 20 stored there, and the address of the next node component shows where the next node is, and there we go and we find that 30 is stored there, and then next node 40 is stored, and then looking at the next we find that it is null, which means that that is a end of the data. So it is trying to say that there are totally four elements in our list: 10, 20, 30, and 40. And to represent that 40 is the last element, we just put a null in the address of the next node. So this just gives an idea, but exactly if we look at it, so we are trying to save seven data, and we found that the blue locations are available for storing, and here we store the first data, then we know the second data is stored here. So from the position where first data is stored to the position where second data is stored, we have an arrow, a link. That means in the address field, we write where the second node is situated. In the address field of second node, we write where the third node is situated, and so on. So we can follow this address, and first location is here, which we usually call head, and then with the element value is 1, then the second location is here, element value is 2, third is here, its value is 3, fourth is here, fifth is here, sixth is here, seventh is here, and there is no further arrow. That means the address of the next node is null here, so that ends. So we can start from the head and go through all these paths and trace what all the nodes are there. So the advantage of this is we don't need seven locations in one place contiguously. We can have one place wherever available, and seven such things if we can use, we can store the seven elements. So this is another way of representation. So if we had a static allocation, if we are using a static allocation like arrays, then these contiguous locations are used for the storing this data. Whereas if we go for dynamic, static means there's a example is array, dynamic means it can be a linked list. So here different positions wherever it is available we can use, and then we can write our data and connect the links so that where is the first data, where is second data, and so on. So that's a basic idea about the linked list. Many more details about linked list to follow. So keep watching. Thank you.